Okay, so here's a quick video of me explaining how you would go about finding the true shape of a cut surface of a hyperboloid of revolution. So to do this, we're going to be working off at this here. So what this is here is it's the outline of a plan and elevation of a cooling tower. And it's in the form, like I was saying, of a hyperboloid of revolution. So what we have to do is we have to draw the given plan and elevation and determine the true shape of the section SS. So as you can see, there's the line SS. We have to determine the true shape of the section. So to construct this in plan and elevation, firstly, we will use an appropriate method. The asymptote method is one we have been going with so far, so that will be the one that we use. I don't have the construction thrown in on this because that is it might get a bit confusing, and I just in this video what I want to focus on is the principles of finding the true shape. So if you're still unsure of any of the elements of actually constructing the hyperboloid of revolution, go back and look at the previous video, or go back and look at the what we have done before on the constructing the hyperboloid of revolution. So in this, just in case, I still have the asymptotes here just to act as a visual, just to show you what they will look like on this question using the true when we are finding the true shape of the section SS. So as you can see, they are demonstrated here by the green lines, and there's the asymptotes crossing then at the throat circle. Okay, so what we are doing then, firstly, what we have to do is we construct our hyperboloid of revolution, okay, in plan and elevation. So once we have that, then what we have to do is we have to select a number of points along the section of the line SS. Okay, so there's our line SS. So what we're going to do is select a number of points. So what I did was I selected 1, 2, and 3 points. Okay. So what we have to do then is take horizontal sections through each of these points. Okay. So these horizontal sections will produce circles in plan. The radii of these sections, right, are R1, R2, and R3. Okay, so where this is on this, so there's our sections. These are our horizontal sections that will create the circles in plan. So there's 1, 2, 3. So the radii that they create, then okay, is so there is R1 from there to there. There is R2 from there to there, and there is R3 from there to there. Okay. So once we have them, then we have found 3 radii. So we will take those radii, for example, R3 here, there to there. We'll bring that down then, and then we'll create R3, the circle R3. Okay, from there to there. The circle then from R2 there to there, and then the circle then from R1 there to there. So now we have our 3 circles in plan. So what we have to do then is we have to project the points A, B, and C from elevation onto the appropriate circles in plan. Okay? So how we do this then is we just bring them down off the points. So we bring this line down, we bring this line down, and we bring this line down. So they're coming down from elevation into plan. And then where they cross the corresponding horizontal section circles down here is where we have our points. Okay, so we'll take this one here, which is our point 2. So we bring this down, and where it crosses our R2 circle, there's 1 point, and there's our second point. That is a point. We repeat this for each of our points A, B, and C, and it will create numerous points that we will join together then to have our section in plan. Okay, so what this actually gets us then is widths. So what we do with these widths then is we use these to create our true shape. So what we have to do to get a true shape is create an auxiliary view. So we create our x1, y1 here, which is parallel to our true shape line SS here, our section line, sorry. And what we do then is we take our widths. So we know that the line SS is on the point here, so that means it's going to be on the line here, and we know that it's on the line here, on the hyperboloid revolution here, so it's going to be on the hyperboloid revolution there. So there's our 2 starting points, because it's not going to be out here because it's obviously just a point in space. So we have our start point and we have our end point. And we project our points out then, okay? So there is our point A coming out, there's our point B coming out, and there's our point C coming out. There, okay? Now, so where are these circles coming up from? Where are these actual widths? These widths are found from plan, okay? So the widths between, we'll use point, let's say here's point B, right? So we'll follow B back. There's B, back to the line SS, and down here. So the width then is from this point here to this point here. That is our width of B, okay? From there to there, right? So we have our width. So we bring that up. We have our center point there, and then we draw our circle. And wherever that crosses our lines then that we've projected up is a point on the surface, which will create our true shape. And we repeat this for points A and C, and that will give us our, there's the circle for A, there's the circle for B that I was talking about, and there's the circle for C. So these will give us our points to create our true shape of the section SS.